Hey guys, welcome back. This is David, and today we're going to go through road corridors, specifically building the assembly, the section view assembly that is used to build a road corridor. Let's learn.
This is making assemblies for road corridors. The first step is going to be to find the road cross section. Most jurisdictions will have a standard details somewhere on their engineering website. For example, for this project, it's City of Atlanta, so we found the City of Atlanta Transportation Department standard details from the ATLDOT website. And then you'd need to find the cross section for the road you're looking at. This is a 50-foot right of way, and we're going to be using condition 1, which is two 8-foot paved lanes, then a 30-inch roll curb, and then the sidewalk. And on this project, we're required to do a grass strip between the sidewalk and the curb. So instead of a 6'6" sidewalk, it'll be 2 feet grass strip and then 4-foot sidewalk. So your first step is going to be creating the assembly. You'll open the assembly drop down and then choose create assembly. Give it a name and leave the assembly style as standard. Hit OK, and then you'll select where the insertion point for the assembly, the sub-assemblies are. Then you're going to go through and use the lane super elevation AOR.
Why?
And click where you want it to insert.
Is it always that? Good. Record all of this is good. This is good stuff.
So once you've inserted your lane, you're going to look back at the cross section from the jurisdiction. Since it's supposed to be 16 feet of pavement for the lane width from the center line, you're going to set the width to 16. Usually the cross slope default slope is going to be 2% or negative 2%, which means it slopes away from the center line at 2%. Sometimes you're going to need different numbers, but most jurisdictions, their standard is 2%. So unless something specifically tells you otherwise, that's just going to be the number you're going to use. Then you need to know the thickness of the different components of the paving. This is the thickness for the Atlanta residential pavement section, which is in their standard detail manual as well. And sometimes jurisdictions will have it on the same detail as their road cross section. Sometimes they'll have the pavement section separate, but that varies jurisdiction to jurisdiction. But you're going to match the pavement depths based on what that pavement section says for the different layers of the pavement. So this one was 1.5 inches of type E coating. Did I do that correctly? Yes. Then you've got 4.5 inches of type B. And I did not type that either. And then there was 4 inches of aggregate base, and then 6 inches of subgrade as part of the cross section. So now all of these depths should match up with the city's detail, which means that this view should, in theory, be scaled to match what these requirements show. So now we're going to add the curb for City of Atlanta. We're using the condition 1, which is the roll curb. So you're going to go to the curbs tab in the subassembly list and select roll curb.
How do you know that that's a roll curb? Because it does, and it doesn't say on there.
So you know that from the different shapes of the curb that it's got in here. This is,
A roll curb.
yeah,
Okay.
pretty
Fair
much.
enough. Cool.
So you're gonna select the curb, and then you'll set all of these dimensions to match whatever the requirement is. And Atlanta has a roll curb detail somewhere in their manual. I don't recall off the top of my head where that is. But you'll go through, you'll set the back height, front height, and all of these dimensions to match what their standard is. So the front height is going to be this spot right here, where the curb meets the pavement, and that measures from the top of the curb down to the base of the concrete. The back height measures the back side of the curb from the top of the curb down to the base of the concrete. You've got your sub-base depth, which is right here. That would be some sort of aggregate usually. Then your flow line height is going to tell them what this depth should be, where the gutter and the roll curb is. Your bottom width is going to be what we change to match the requirement from Atlanta, which is a 2'6" curb. So that would be 30 inches wide. So that just measures from front to back how wide the curb is. Then your width to your flow line is going to tell where the low point should be. And then let's see what else is there. I think that's everything. So now we're gonna add a sidewalk. So we'll use the basic sidewalk, add it to the starting point there. And now we're gonna go in and set the width of pavement to match Atlanta's requirement for residential, which was the 4-foot curb with a 2-foot grass strip between the sidewalk and the curb. The depth is for a sidewalk is usually going to be 4 inches, which Atlanta has shown in here. So, and then buffer width is going to be the width of the grass strip, so we're going to do 2 feet for that. And now that gives us the entire cross section of going from the center line out in one direction. So now we're going to mirror this. So first you're going to click the component you want to mirror. Then for the road coming off the center line, you're going to use copy. And then you'll select the assembly starting point. And then you'll click the subassembly and change the side to the other side, whichever direction you started with. And now we'll select the curb, copy that, and let it go to the opposite side, and then change the side in the properties. And we'll do the same thing for the sidewalk. and select the point you want it to deposit to. Then change the side. So now I have both of them selected when I change the side. So now we've got the mirrored cross section that matches Atlanta's requirement. So now you'd use this to create the corridor for the residential street in Atlanta. And you do the same thing for any jurisdiction. This one is Cherokee County and Metro Atlanta. So they've got several different types of streets to look at. Some of them don't have curb. The rural streets are just pavement, and then different shoulder types with different slopes on them. They've got curb on their urban streets, and then they've got different pavement widths. So this one's 10 feet from the center line, 2 foot standard curb, and then 5 feet to the center line of the sidewalk. I don't know why they labeled the dimension like that, but not everybody does things that always make sense. But you'd follow the same process for creating one of these. Let's see, what is important on here that we don't have shown already? Let's see, let's add the sidewalk right here and show how that's done. Or not sidewalk, add the ditch. So the way you're gonna do that, you're going to go to the generic subassemblies list, and then depending on what the requirement is, we'll change which one of these you use. With the way that Cherokee County has these laid out, we're gonna use link, offset, and slope. So now you click the subassembly, you tell it how wide they want that portion of the slope. So for this ditch, it's 8 feet wide at 1.5 inches per 1 foot, which should be, or 1/2 inch per foot, which is about 4%. And it's negative since they have it sloping down. Then link, offset, and slope again. And now we do 6 feet wide. 3-to-1 slope is negative 33%. So now we've gone down to this point. And now we go to the daylight, which should, where is it? I think it's this one. So you can also build the ditch using the daylight general entirely. You'd have each of these dimensions. You've got the width for each step. So let's see. So if we want to match the Cherokee County ditch dimensions, you know what, I'll get rid of those and we can just build it entirely off of here. So the cut width 1 is the 8 foot at 4%. Cut width 2 is 6 at -3 to 1. And then cut width 3 is 7 feet. And for whatever reason, they don't have this slope labeled, but on this side they're showing it as 2 to 1. So that would be 2 to 1. And then, where is it? Where are you? And then you'd use the cut slope that's not numbered it will just create the generic slope once you get outside of your design dimensions that just continues in whatever direction you're telling it to go. So here these go up at 2 to 1 in the cut slope, which is this arrow right here. And depending, some places will have requirements based on the height of the slope about what the allowable slope is. And you'd use the flat cut max height and flat cut slope, the medium cut max height, medium cut slope, and then the steep cut slope to control that to match whatever their jurisdiction's requirements are. And then you'd go through and do the same thing with the fill. So we'll match 8 at -4%. And then 6, -3 to 1. And then, let's see, 7, 2 to 1. So now that sets up for the ditch along the road for a fill slope. Why did I do that? There we go. So now it's set up to, no matter whether we're above grade or below grade, it's going to create the corridor out to this point with the ditch in, and then it's going to run out from there to go to whatever the target surface we've set is. So that is that's using the daylight general to create the ditch clear zone. And jurisdictions will have requirements about that. GDOT has their own standards for clear zone requirements. ATL DOT does as well. And I believe that covers the basics of getting an assembly set up.